wonderful to know that how the scientists and mathematics to solve this massive and the complex form of the equation. Let me introduce about the Gauss-Seidel method in today's class. Hi, hello everyone. Myself Dr. Kirti Zare. Today I am going to introduce you about how the scientist or the mathematician is going to simplify the complex form of the equation through the Gauss-Seidel method. The same method like the Newton-Raphson, bisection, secant, golden search method, Muller method. This is also the iterative type of the method. But it can be utilized into the linear form of the systems. Different type of the key applications of this particularly Gauss-Seidel's method, which can be generally including into the electric circuit. By using the Kirchhoff law, you can calculate the electricity voltage through this particular type of the method. It can be also utilized into the fluid mechanics, in which you are supposed to use the complex form of the Navier-Stokes equation. With the help of this method, you can simplify the any problems over there. It can be also utilized into the civil engineering field to calculate the structural beams, displacements, and so on. So there are the different type of the applications of this Gauss-Seidel method as well. So let us start with this particularly numericals through the Gauss-Seidel's method, right? So they are giving this set of the equation, right? That is the linear form of the equation. So they are going to ask that find the values of this x, y and the z using the Gauss-Seidel method. Here they are asking for the 6 iterations, right? Generally, some of the time in the numericals they are already mentioned, so there is no issues of that how much the iteration or how much the trial that you have to take. Here or in the some of the methods they are already mentioned, so you can just do for the that particularly form of the iterations, right? Whenever you are going to talk about the mathematics subject, so at that time the accuracy should be the higher one, right? So let us start for this particularly form of the methods. So firstly, you can note at this as the first equation, this as the second equation, and this as the fourth equation. Now from the first equation you are supposed to find out that which one is the dominant factor over there with respect to the x, y and the z. If you are going to see the 4x means this is the coordinator of the x is the 4, while here y and the z is the 1 1, right? So definitely first step is that you are supposed to write this equation in the form of the x. In the same manner, for the second equation, the dominant factor becomes the y. So you have to write the equation into the y form. And thirdly, that is nothing but the z. So you are supposed to write the equation in the form of the z. Means simply you have to rearrange it, right? So let us start for this. So firstly, calculate the x from here. That is nothing but x is equal to the, you can just rearrange it, right? So you are getting the value become the 5 minus y minus the z, right? Next manner that you are supposed to calculate the y from here. So you can quickly rearrange it. That is the 19 minus x minus 2z, right? Minus 10 minus x minus 2y divided by the 5, right? Only you can just reshuffle in terms of the minus sign, right? So this is our set of the equation, but they have not mentioned the what should be the initially guesses over there. So you can start with the 0 point because you don't have the values of the yz or the x at the initial to calculate the xyz for the different iteration, right? So let us just do for the iteration number 1. For the iteration number 1, so you are supposed to consider the y and the Z value become the 0, right? So just put over here that x is equal to again 5 minus 0 minus 0 divided by the 4. Eating the value become the 1.25, right? Similarly manner for the y. Now you have to, now initially you are supposed to consider y is equal to the 0, z is equal to the 0. But now you are already computed the value of the x over here. So you are supposed to consider the x value over here, right? So that value become the 90 minus 1.25 minus 2 into the z value become the 0, right? Divided by the 6. 2.958, right? Similarly, we just do for the z. Now same concept you are supposed to utilize over here, because now you must be know the value of x and the 2y. So you are already calculate the x value over here. That become the 1.25 and the y value become the 2.958. So you are supposed to consider that value. Minus 10 minus x value become the 1.25. Again this is the minus 2 multiplied by the y value become the 2.958. This whole divided by the again x become what? 5. Now you are supposed to put this new value of y and the z over here, right? 5 minus 2.958 minus, again it become the plus, that is the 3.433 divided by the 4, right? X value become the 1.368, right? So you can just note here from the iteration number 2, you are getting the x value become the 1.368, right? Similarly we just go for the iteration second. So that is the 19 minus 1.368. Now again you are supposed to consider this new value, right? Minus 2 multiplied by the z value become the minus 3.433 divided by the 6, 4.083, right? Similarly way we are supposed to calculate for the z. Again now you are supposed to consider this new value, not the previous one value over here, right? Minus 10 minus 1.368 minus 2 multiplied by 4.083 divided by the 5. Right? Become the minus 3.0968, right? So z value become the minus 3.0968. Number 2. Similarly we just go for the iteration number 3rd, that is equal to the 5 minus 4.083 minus into bracket, otherwise you can directly take as a plus, right? Divided by the 4. If you are going to solving this 1.205, right? So for the iteration number 3, you are getting the x value become the 1.205, right? Similarly we calculate for the y, that is the 19 minus 1.205 minus 2 multiplied by the this value, that is the minus 0.968 divided by the similarly manner calculate the z value, that is the minus 10 minus this new value of x, that is 1.205 minus 2 multiplied by the 4.268 divided by the 5, right? 0.94. right? So Z value become the minus 3.94. So this is with manner you are supposed to calculate for the iteration number 4, right? So now for the iteration number 4, x value again 5 minus this new y value, that is minus 4.268, again minus 3.94 divided by the 4.168, right? Similarly manner, calculate the y, that is the 19 minus this new x value, that is the 1.168 minus 2 multiply by the z, means this value, previous value, because you are still not calculate the z value over here, divided by the 6. So y value become the 4.285. Y value become the 4.285, right? Similarly manner, calculate for the z value, that is equal to the minus 10 minus 1.168 minus 2 multiply by 4.285 divided by the 5 is 3.9476, right? So z value become the minus 3.9476, right? So this is accordingly the iteration number 4. Just go for the iteration number 5 and the 6. Supposed to calculate the value for the iteration number 5. Similarly, you are supposed to calculate the iteration number 5 accordingly the numerical statement. So just do the calculation, that is the 5 minus this y value, that is 4.85 minus z. So it is already into the minus, so you can directly take as a plus 3.9476 divided by the 5. 18 minus 1.165 minus 2 multiply by the, this is into the again minus 3.9476 divided by the 6, right? So y value become the 85. So y value become the 4.285. Calculate the z value again from this new value of x and y, minus 10 minus 1.165 minus 2 multiply by the this new value of y, that is equal to 2 multiply by 4.285 divided by the 5 minus 3.94. So z value become the minus 3.94, right? Minus 3.94 divided by the 4, right? From the 1.168. Y value, that is equal to the 19 minus 1.168 minus 2 multiply by this z value, that is equal to the minus 3.94 divided by the 6.286. Similarly way, just do the calculation for the z. So y become the 4.286. So let's do the calculations for the z, that is the minus 10 minus this new value of x minus 2 multiply by 4.286 divided by the 5.947, right? Similarly, form of the iterations x, y and the z value. If you are going to observing this particularly different values, so in that you can note that the all whatever the x, y or the z value that you are calculated over here, so that are the nearby values of the first iteration, second iterations and the third iteration. But generally these all things is depending upon that how much you want the accuracy. So it is also simply depending upon that how much the error they can be sustained for a particularly system or for a particularly problems. So with respect to that, they must be set this value also, right? I hope that you can understand this simplified form of the Gauss-Seidel methods. So please subscribe, like, share my channel, and if you have any doubt, so you can also write your doubt into the comment box. I am too much happy to solving that particularly form of the equations.